Mira, can you get the light? It's getting a bit bright now. Sandwich today? What did you get for lunch? Oh, I had those before. They're nice.
Really?
Yeah, I like them. Yeah. What else did you get? Sandwich as well. They must think you get hungry.
No, I make it.
Oh, you made your sandwich. You have sandwich and pasta. And you'll eat it all?
I'm hungry now.
Yeah.
Can I eat?
Did you have breakfast? You had breakfast and you're hungry now? No. If you said you didn't have breakfast, then yes.
But it's not cereal. It takes too much hours to get here.
What do you want to eat? Your sandwich? Go ahead. Don't make a mess, okay? You can eat some of it. Please be clean. No crumbs. Thank you. Did you have breakfast? No. Did you have breakfast? Yes. Breakfast? Breakfast? Yeah. No, I understand, Fuan. I had breakfast and I'm also feeling a little hungry. I think I could do with some toast maybe, something like this. Yeah, okay. So the next lesson is called the Quotient Rule. Yeah. So we'll start off again. Y equals f over g. And you can probably guess what I'm going to say first. The derivative is not. Very good. So this is not what it is, but you're right. And let's look at a simple example to show it's not this. So for example, what's the derivative of 1? It should be 0, correct? 1 is the same as x over x, isn't it? What's the derivative of x? 1. What's the derivative of x? 1. What's 1 over 1? 1. But it's not supposed to be 1, it's supposed to be 0. So again, we can see it's not this. It's not this. Okay, you don't have to write that down, but the next part you do have to write down, which is the rule. Continue? Oh yeah. Yeah, that one, I get that one, yeah. Yeah, I think keep going. There we go. That's as good as it's going to get. Yeah. Okay. What is that? What's in it?
Chocolate.
Chocolate? You made a chocolate sandwich? Of course, I'm the crazy one for asking. Alright. Right, let's have a look. Y equals fx over gx. And we want to calculate the derivative. So, what method do we use? First principles, like the last example. Okay, so this one is a little bit harder, but it's still the same idea. It's x plus h minus x all over h. And now we have to simplify it. So I'll just give you a minute to write this down, okay? So I'd like you to write down the proof. Even though you don't need the proof for your exam, it's still good for your mental well-being and health. Yep, okay. So last time you remember I did a little trick to simplify it a bit. And again, it's the same idea here, but before I do that, I should try and put this together. So I don't know how you saw it with Roland, but the way I put these together is as follows. All over h. So it's gx plus h times gx. So it's gx plus h times gx, and then you do a cross. This times this minus this one times this one. That's how I add my fractions together. Of course, there are many other ways to do it. This is just the quickest, most straightforward way for me to do it without thinking. So you multiply the denominators to make this denominator, and then you cross it. So you end up with gx fx plus h minus fx gx plus h. And like I said, that's not the only way to do it. It's just for me mentally the easiest way. Is that a good chocolate sandwich? Let's see the inside. Yeah. What type of chocolate? Nutella? Ah, Nutella's nice. But it's delicious. It's expensive but delicious. You know the spread? Nutella?
It's worth it.
Huh? It's worth it. Yeah, no matter how much, it's worth it. Oh yeah, I have chocolates for you. I forgot to bring them to class. I had chocolates left over from Christmas. I got too many sweets for Christmas. I'll bring you in next time. Okay, can I go to the next step? So, next what I'll do is I'll multiply the top by 1 over h and the bottom by 1 over h. So this and this cancels, and then the h multiplies this, so it's like a h here now. So now you have only one fraction, which is a little bit better. Gx plus h, gx, h. And here you have gx fx plus h minus let me keep it the same way around.
The multiplied by 1 over h is there for the, like when we add them, when we put the like base by base.
Yeah. Now I left a big space in the middle, and the reason I left a big space in the middle, you can probably guess, is I'm going to do the same trick as before. I'm going to add and subtract the same thing to make a 0 in the middle. So I'm going to add and subtract. So I'm going to do minus fx gx plus fx gx. They'll both cancel anyways. So I haven't really changed the fraction. But what's in common in the first two here? Gx. And what's in common in these two? Fx. So let me take out gx. So I have gx bracket fx, well I'll put in the bracket, fx plus h minus fx. Now just be careful, I'm actually going to take out minus fx. I'm going to take the minus fx out. So I'm left with gx plus h minus fx, minus gx. So I'm taking a minus out, not the plus. All over gx plus h, gx and h. Okay, only one line left. What I'm going to do is I'm going to take this one and put it over the h. Yeah, I'm going to divide both of these by the h. So now I have gx fx plus h, sorry that's a minus there, minus fx over h minus fx gx plus h minus gx over h all over gx plus h gx. What happens when, yeah? Nearly there. What happens when h becomes 0? So what happens to this when h becomes 0? No, not this again. No. No, we did this in the last class.
F of
X.
derivative F.
Yes. F dash, F derivative. So this becomes gx, F derivative x, minus fx, g derivative x, and what do we get on the bottom?
G.
When h is 0.
Yes.
Thank you. Gx squared. So we have our answer. If y equals f over g, then that means dy dx, the derivative will equal the bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom.
What's h in
Oh, I can't really say that because you did that in semester 1, so I'd be going backwards, which isn't great. I would suggest watching the video on this one. The lesson's called First Principles. This will explain the H. Unfortunately, Adnan, you have the biggest of the 3 maths courses. Engineering maths has more in it than the business or the science, so I don't really have the luxury of revising things from semester 1. Now, towards the end of the semester, if there's a surplus of time, which there should be, then we can look at revision of semester 1, but I'd rather get semester 2 finished before going with that yet. And anyways, we'll need to revise semester 1 because it's in the final exam. Okay, did you write this down? So this is called the quotient rule. Let's have a look at an example to see that it works. Can I scroll down? Mir?
Last 2.
Last 2, okay. Good sandwich?
Still hungry.
Ah, no. Still hungry? You're okay?
I'm getting fat.
You're getting fat being in Ireland. You walk to school? No, you do.
Bus and walk.
Bus and walk. Okay. Maybe you should cycle to school on a bicycle. Then you can have all the chocolate sandwiches you want. Okay, got this? Can I scroll down there?
Yeah.
Okay, so let's look at the example I did earlier where I said y equals 1, the derivative should equal 0. So if I say y equals x over x, what should the derivative be? Because x over x is 1. Let's test it out. So this is f and this is g. So the rule is g squared. What's g squared?
No, GX.
Oh, it's down at the bottom, yeah. The bottom squared, and then g times derivative of the top. So it's x times derivative of x, so that's x times 1. Minus the top times derivative of the bottom, which is 1. So 0 over x squared, which is 0. So hey, the rule works. Okay, so let's have a look at some actual examples now. Here's our first example.
So it's the same as the first one, but divided by the...
No, you don't even have to worry about this example. I'm trying to prove to you that the rule works. If you believe me, then you can forget about this screen. That's all. Okay, so let's have a look at our first real example. So let's say we have something like... Oh, actually, let's do an example where we know the answer. Y equals sin x over cos x. Tan x, and what's the derivative of tan? 1 over cos squared. Let's see if we get 1 over cos squared. Okay, so the rule is the bottom squared, the bottom times derivative of the top. What's the derivative of sine? Cos. Minus the top times derivative of the bottom. Minus cos. Oh, sorry. Minus sine, I meant to say. Minus sine. Derivative of cos is minus sine. Yeah. Yeah, it will be plus in the end, yeah. So cos squared x plus sine squared x all over cos squared x. Who knows what cos squared plus sine squared is?
1.
Again, more evidence that the rule works. I've seen this one in the exam. It was like a question that said, like, prove derivative of tan x is 1 over cos squared x. So, you know, this is the proof. You know these words now, don't you? Derivative is the noun. What's the verb? Derivative? No. Derivative? No. What is it? Forgot?
Stop.
The noun is derivative and the verb is differentiate. Good. Good. Say it 10 times at home. Derivative is the noun, differentiate is the verb. Yes.
Is it
So difficult. Okay, you wrote this down? Right. Let me give you one to try. Won't make it too difficult. Let's say something like y equals ex over x. See what you can get with this. Late shift last night? No? You look tired.
Home at 3.
This would explain it. You were having a good time at least?
No, I'm having, pain in my throat.
Oh yes, okay. So why were you home at 3?
I was having
Oh yeah, so you had a late
morning.
shift.
Yeah, 7 in the morning till 3 in the afternoon.
Well, 3 in the afternoon, not 3 a.m.
No.
I thought you were working until 3 a.m. 7 a.m. to 3 a.m.
8 hours.
Finished wrong? What answer did you get?
EVX
Yeah?
multiply x minus 1 over x squared.
Did you take ex out?
Yeah.
So it's ex, what's this called? Bracket.
Bracket.
Yes. Come on, wrong. Who's your EAP teacher?
David.
Okay.
Isabel.
Yes.
And Connor.
Ah, okay. EAP is difficult? Right, let's have a look here. Right. So it's the bottom squared, the bottom times derivative of the top minus the top times derivative of the bottom. What can we take out? Take out ex. Ex bracket x minus 1 over x squared. Bracket. Alright, we got this? Yeah, right. Let me start giving you a trickier one now. I want to see how you'll deal with this one. So this one, y equals ex sine x over x. Now, this will be our first question, which is like an exam question. This is the type of question you might get in section A of the exam. In fact, this is very commonly an A1 question, the first question on your exam. So see what you can do with this.
Use the multiplier.
Yeah, we need both. You got it, Musharif? Easy? Hard? So-so. Well, we went straight into teaching. I forgot to ask if you had a good winter break. Did anybody go back home?
I did.
You went back home?
Yeah.
Good weather?
Yeah, very.
You got to see the sun again?
Yeah.
Just feel some heat?
Oh, it was very good.
It's probably very nice now in December in your home country. Looks like 30, 25?
No, not well, 20. Not really.
20 to 15? Oh, that's nice.
Even in the morning? Yeah.
15 to 20 is nice. Hot, but not too hot.
Yeah. No,
Still cool.
In Saudi Arabia, 20 and 15 is cold, yeah. Well, in Alpha.
What's your hometown?
I live in Alpha.
I don't know this hometown.
South
What? Give it to me. Reference it to the nearest town I might know.
Do you know where Jeddah is?
Yes.
Like 700 kilometers to the south.
Oh, that's still far away from the nearest town I know. Okay. To the south.
Yeah.
Yes. Okay. Okay, so yeah, 15, 20 is good. Good.
It's a mountain climate.
Yeah, higher elevation.
Yeah.
Ah, that's why it's a bit cooler. Okay. So is there a possibility of snow?
No, not that cold.
Not that cold, yeah, okay. Not even at night, maybe? Does it go to freezing at night?
Maybe in particular places.
Yeah.
There's a mountain called 101 kilometers.
Ah, maybe some... Yeah, okay.
Maybe a bit, yeah.
Sharif, I think you're trying to hurt me. English only, please. Okay, let's have a look at this. So, Adnan, you figured it out, and maybe others figured it out as well, that you need both rules here. But the big question is, which rule to use first? Product or quotient? You're saying product? Anyone else want to commit? You're saying quotient? Great. You're saying? You're saying?
I use product, I don't know.
Product first? Quotient first. The answer is quotient. And the reason is, this is a fraction before it's anything else. So first we have y equals something over something. And it just so happens that what's on the top is a product and what's on the bottom is something else. So you need the quotient rule first, because first it's a fraction. Secondly, it has a multiplication. Okay. So if I use the quotient rule, the bottom squared, the bottom times derivative of the top. What rule do I need now? Product rule, which will be ex sine x plus ex cos x minus the top times derivative of the bottom, which is 1. So the answer is ex sine x plus ex cos x minus ex sine x all over x squared. So what can I take out to finish? Yeah, I could take it out. If I just want to take one thing out, ex, yeah. So I'll take ex over x squared, and I'm left with x sine x plus cos x minus sine x. And you don't have to. In fact, in the exam you can stop here. But if you want to simplify a little bit more, you could then say ex x squared bracket sine x bracket x minus 1 plus cos x. Yeah. Now, like I said, you can stop here in the exam and still get full marks. They never ask you to simplify. So stopping here is totally fine, okay? You might need to write this down.
If we not stop at where we
Continue.
yeah, and the continue is wrong, but the thing you stop is right. So
It's tough. It's tough. It's tough. It's a tough call to make. Sometimes I give the marks, full marks. I mean, it's a tough choice I have to make. You know. So I'm looking at it, I'm like, this is the right answer, but she didn't stop. What do I do? It's a tough decision. 50-50. Don't do it. Just be safe and stop here. Yeah? Okay. When you're ready, I'll give you another one to try. How about, can I scroll down? I'll give you a simple one to try just to practice a bit more. Try this one. Ex over sin x. Oh, I didn't tell you. I got a tablet for Christmas, and I'm so happy. So happy. Samsung tablet. I have it in my bag. I'll show you sometime. My second tablet, because a month ago the biology teacher gave me his old tablet that he was going to throw out. I said, I'll take it.
I remember that story.
Yes. Now I have a new tablet.
Did you bought the battery?
I did. It should come in this week. Yeah, I got it from China, so it should be here this week, I hope. This will make things easier. Okay, did we get the answer here? Yeah, so what did we get? What's on the bottom? Sine squared. And on the top, you can probably take out ex. So you have ex bracket. Oh, we have a plus and a minus issue here. Well, let's better see which one it is. So, it's the bottom squared, the bottom times the root of the top minus the top times derivative of the bottom. So it's EX sine X minus cos X. All over sine squared X. Yeah. So, if I said to you, find the turning points, what would you have to do next? Equals 0. Now this is actually interesting because you have EX sine, well, nearly the same, except we just have to be very, very, very careful here. So you have two choices. Either EX equals 0 or sin X minus cos X equals 0. Because the only way to make 0 when you have a fraction is if the top is 0. That's the only way. So it must be that sin X minus cos X equals 0. And we've seen this one earlier, didn't we? However, there's one extra addition here you must make. You must also say, and sin X cannot be 0. So if one of your answers makes sin X 0, you cannot use this answer. It's not allowed. Yes. Now that's okay, because the two answers I got here, what were they? Like pi over 4 and 5 pi over 4. And neither of these answers make sin X 0, so both can be accepted. 2 t's are 1 and accepted. Doesn't matter. Both of them can be accepted. Yeah. You just need to be careful with that, because sometimes in the exam the student might get 2 or 3 answers, but one of the answers has to be rejected because the denominator will be 0. So just please be careful with that. Okay, so in the exam they like to give you questions that mix the two rules. I think I have 9 years of exams, and in all the 9 years they've never given you a question that needs only one rule. It's always questions that need at least 2 rules. Okay, so we could have a product and a quotient. Yeah, or sometimes you could have a product and a product like we had earlier, I suppose. You know, when we had something like EX sin X cos X. You need the product rule twice here. You get what I'm saying? In the exam, it's usually a 2-rule problem. Okay, how are we doing for time? Okay, I think we'll have to wrap it up there. So, again, I'm treating you like adults. You need to decide what you need to do for homework. Yeah. We still have a tutorial once a week. We'll make the tutorial, I think, it doesn't really matter because we're all in the same group of 5 for every class. So we'll just make the tutorial the last hour of the week. So whatever the last hour of maths is, that will be a tutorial.
Why you don't do it like the physics every lesson and we do the...
Say again?
Can we do when like we do in physics tutorial in every lecture, we do the homework from the...
The problem with the maths is
there is no specific one.
Well, not with that, but also just the time. You see, I suppose we could try it. We could try that. If you're okay with that, guys, listen. What Musharif was suggesting is rather than having a tutorial 1 hour a week, we can do some questions from the homework at the start of the class. But if this doesn't work, I'll have to switch it back to 1 hour a week for the tutorial. We'll try it. We'll try it this way, okay? So in the next class, you can ask me some questions from your homework at the start. I'll do 2 or 3 questions and then we'll go on to the next topic. Okay. We'll see how that works.